Sometimes it helps to sort the rows in the output table. SQL allows to do so using the order by clause. There we can specify sorting criteria for the tuples in the output table. This is useful first of all to improve human readability, but also if you have application programs that want to retrieve only a partial number of results, so only, let's say, the first 100 results, then it makes sense to define an order such that this is not a random selection of the results, but the first 100 with respect to a particular order. SQL allows to use the order by clause for specifying sorting criteria for the output tuples. Without the use of order by, the order of the output tuples is more or less random. It depends on the internal algorithms of the database management system, it depends on the query optimizer, and it can even change from query to query because the database management system may choose a different strategy for evaluating the query. So we can specify sorting criteria in the order by clause. We specify a list of attributes, and for each attribute we specify whether the ordering is ascending or descending. If we do not write ascending or descending, then the default is ascending. If we give more than one attribute, then the comparison is in the order of the attributes provided, so it's lexicographic comparison. First we compare the first attribute. If this is a tie, then we compare the second attribute. And if this is also a tie, then we compare the third attribute, and so on. This slide shows an example use of the order by clause. Here we are querying the students and the results table. We are looking only at those results that belong to the student and only at homework results. In the output, we are using the following order on the rows. First of all, we are ordering by the homework number. If the numbers differ, then this already decides the order on our rows. Only if we are within the same homework number, then we are comparing the points that the students have obtained on this homework. And we are ordering the points in descending order. So we are first listing the students with the best result for this homework. And if we still have a tie, we compare the last name. And if this also still gives a tie, then we also compare the first name. So this query will give us this table. We have first of all ordered by the homework number. Within the homework, we've ordered by the number of points in descending order. And if there would still be a tie, in this case we don't have a tie, then we would first compare by last name and then by first name. In some application scenarios, it's necessary to introduce additional columns in order to obtain suitable sorting criteria. So for instance, if you imagine that we have a database where we have a single column name that stores just a simple string combining the first and the last name, so just George space Orwell, then it's very difficult to sort by last name. Then it's better to have two columns, one with the first name and one with the last name. For null values, the treatment is unfortunately not uniform across different database management systems. Some database management systems list null values first, others list them last. Importantly, order by is only cosmetic. Therefore, it's not allowed to apply order by to a subquery.